Okay. I would like to apologize before starting because I am a little ill of the throat, so sorry about making some weird noises. Okay. So good afternoon, everybody. My name is Ramón, and I work for eventlama.com. Thanks for coming to see this presentation. Really appreciate it, and also thanks to the organizers for making this also GopherCon in South America. I work on eventlama.com as a software engineer. eventlama is also an event management application, which is used by some of the biggest developer conferences in Europe. And on spare time, I like to and try to contribute to the Go community. Mainly, I contribute to the Graphql-go library. So this is the agenda for the presentation of today. First, I'm going to do a brief introduction of GraphQL. Then we will be exploring the Graphql-go library. I will talk about the history, the architecture, and the challenges that appear on the road while in the library, and also the community around the library. Hola. Okay. And finally, I'm going to talk about next steps that might help us to take the library to the first stable version. So what is GraphQL? GraphQL is a query language and a runtime for applications. It's agnostic to the programming language and the data store, meaning we can implement it as an extra layer in our servers. We can use GraphQL to create interactions between servers and clients. With GraphQL, servers can expose their capabilities, and clients can query for data, can mutate data, and or can subscribe to events. GraphQL was created at Facebook in 2012, and since then they are using on production. The specification was released in 2014 along the JavaScript reference implementation. And today there are many implementations in different programming languages. One of them is the Graphql-go library, which is the topic of this presentation. So let's explore the GraphQL concepts with a step-by-step diagram. Let's say we have a server which has a GraphQL layer implemented on it. And also we have a client, which could be any front end really. For example, let's say it's a mobile application. And this mobile application has a small view where it needs to display the GitHub information of the current user, or the viewer as it's called by the GitHub API. Let's say the current user is the AutoCAD GitHub user. So in order to display the avatar, the login or username, and the email of the viewer, the mobile application needs to obtain that data from the server. So the mobile application sends an HTTP request to the server, to the GraphQL endpoint. And how does the HTTP body looks like for this request? Well, here is where the GraphQL syntax comes in. It's quite similar like JSON, but only with keys. And as you can see, the mobile application only requests the data it's needed, the the avatar URL, the login, the email. There is no overfetching or underfetching of data. So the server, which has a GraphQL layer implemented, receives the request, executes the query string, and returns the result. And as we can see in the result, in the response, it's a JSON format. And it has the same shape as the query string that was sent to the server. It only contains the data that was requested by the mobile application. Nothing less, nothing more. And now the mobile application can use that data to render the view that is needed. So this is how the clients can query for data using GraphQL. Now let's explore how clients can mutate data on the server. So in this example, now the mobile application has a view where the current user can create a project for a given GitHub repository. There are only two fields required, the name and the body, or description for this project. So again, the mobile application sends an HTTP request to the GraphQL endpoint. And how does the HTTP request body looks like for this request? Again, here is where the GraphQL syntax comes in. Now it's a mutation, it's a string, query string. Let's explore it step by step. First, we define that the query string is a mutation one. So we define it on the top of the query. Then we specify the name of the mutation. In this case, we want to create a project. We want the server to execute that mutation. And then we specify the arguments that we are going to send to the server, so it can be used on the server to create a project. Next, we can specify which fields we want back from the server for this project, for the project type. So the server is going to return those fields that we specify on the query. After the mutation is successfully executed, we are going to receive those fields. So this mutation is sent to the server. The server receives it, executes it, and returns the result. And how the result looks like? Well, it's in JSON format again, and it contains only the data that we specified for the project type. It only contains that field that was requested. And as you can see, the shape is the same. So this example is how we can successfully create mutations on the server using GraphQL. Now, let's explore the Graphql-go library. After the GraphQL specification was announced in 2015, I got really excited about GraphQL, and I wanted to use it in the Go programs that I write. But at that time, there was no stable libraries that I could be using. Only there was on GitHub some interesting experimental implementations created by other developers. Since I couldn't find one that I could use in production, I decided to write one implementation. And I started it on mid-July 2015. And the strategy, right from the beginning, was to follow the the GraphQL JavaScript reference implementation and to keep parity with it. The current version of Graphql-go is in parity with the version of GraphQL.js 0.5, and we successfully have 100% parity of the test that GraphQL.js have. Also, there are about 17 people that had successfully contributed to the library from different places all over the world. And we are happy to announce that we are heading to the 1.0 alpha version of the library and looking forward to ship it in the upcoming weeks. And also we are going to add more GraphQL-go members so we can work all together and make the library more stable, fast, and simple for the users, for the end user. So, since some weeks ago we reactivated the development towards the 1.0 version. Now, let's explore how we can use the library in order to create interactions between servers and clients. One second, please. Okay, now let's explore how we can use the library in order to create interactions between servers and clients. GraphQL servers expose their capabilities to clients through schemas. Meaning, schemas are we define how clients interact with servers via queries or mutations, as we can see here in this example. For this schema, we have two fields, a query and mutation. For the query, we can define which fields are can be queried from the client. In this example, clients can get the current user can get a single contact or can get a list of contacts. And for the mutation, clients can mutate something. In this case, can create a contact. For example, for the current user field, we define using the GraphQL field type. Next, we define what is the type of this field. In this case, it's the user type. And here down, we define the user type. And we can define which fields are for this user type. In this case, we have 4 fields. And also we have to define what is the type of each field. And one important part is the resolve function, which we can use to write the code logic that is going to be executed each time this field is required. In this case, we are just grabbing the current user from the request context and returning it. Here, we have an example, which we have a query, and we request the current user, and we request 2 fields, the ID and the first name. And we use a function get, a helper function to submit this query string to a local server, which has GraphQL-go implemented on it. So if we execute it, we expect to receive the ID and the first name of the current user. And here we receive the result in JSON, the first name and the ID. Next, we can define mutations. In this case, we have an example for the create contact field. Here again, we have to define the type of the field. In this case, it's a contact type, which is this one. And again, we have to define the fields for this type. We have ID, first name, last name, phone number, email, and address. And for each field, we have to define which is the type. If we go back and we see the result function, it's a more complex one. Here, we use the arguments that are sent from the client. But first, we have to define it before in the field config argument. Here we define which arguments are we expecting from the client. So we can use it within the result function in order to create a contact. And then we can do what is needed with the contact. In this case, we are saving it to the database. Let's try to run this query string mutation. We are creating a contact and we are providing a first name and email data. The first name is Gopher number 2 and the email gopher@email.com. And we are telling the server that we want the ID, the first name, and the email back from the server when this mutation is successfully executed. And again, we are using a helper function to send this query to the GraphQL endpoint. If we execute it, we receive the fields that we are requesting. So this is the top priorities that, from my humble opinion, we should be focusing on to reach the first stable version. Some of them are pretty obvious, but let's explore them. First, I think we have a lot of bugs in the library that was reported on GitHub. So we should be tackling those bugs first. Then we should get back the parity with the latest GraphQL JavaScript reference implementation. Then close some PRs and issues that are labeled as a 1.0 alpha. Then there is many room for the API improvements so the end users can see more easy use the library. Especially when defining the schemas, can be some cumbersome and not that easy. Also, there is some starting performance improvements by some of the contributors, which are very interesting. I think we should make sure some big query strings and some big query mutations are not that slow. And we should define a baseline in order to make sure that the library is not very slow. And also, there are some space for improving documentation. I think we should be improving those. And adding more examples, especially those examples that are real use cases for production applications. So in regards to the community, I'm really happy to say that the community around the library is being so nice and helpful. The library had caught attention from many contributors, and they have been helping us since the beginning. For example, there are some other related libraries, like the Graphql-go handler, the GraphQL relay Go, and the GraphQL relay starter kit. And I want to say a special thanks to the Soho contributor, which is been helping us since right at the beginning. For example, this was the first pull request that he sent. It was really awesome because he basically rewrote all the strategy that we were using for handle errors. And he rewrote everything to be Go idiomatic. It was really awesome. I would like to finish this talk by saying that there are tons of great Go libraries out there, and many of them, from my humble opinion, need your help. And there are many ways of doing so, from documentation, code, reporting bugs, and so on. So please contribute, do share, and we together can have an even more also Go community. My name is Ramón, thank you.
Gracias, Chris.